Michio Kaku, the renowned theoretical physicist, recently revealed a startling finding uncovered by the James Webb Space Telescope. The problem? The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. 6 enormous galaxies, each around the size of the Milky Way, have recently been discovered by NASA's multi-billion-dollar telescope, a collection of ancient galaxies that shouldn't exist since they are so huge. The 6 enormous galaxies, which formed only 500 to 700 million years after the Big Bang but contained nearly as many stars as the Milky Way, have been termed universe breakers by the team of researchers that discovered them. That's because, if they're real, the discovery puts into question everything we know about how galaxies develop. It is not expected that the early universe would be able to organize itself that quickly. These galaxies theoretically should not have had time to form. One of the researchers that contributed to the discovery is Erica Nelson, an assistant professor of astrophysics at the University of Colorado Boulder. While cosmologists have previously calculated that the process started slowly, taking shape within the first few 100 million years after the Big Bang, scientists do not know precisely when the earliest star clusters started to combine into the origins of the galaxies we see today. According to mainstream ideas, these early proto-galaxies reached adolescence between 1 and 2 billion years after the universe's creation, developing into dwarf galaxies that started consuming one another to evolve into ones like our own Milky Way galaxy. Since light moves across space at a constant speed in a vacuum, the further into the universe we gaze, the more distant light we are able to intercept, and the more into the past we can view. Astronomers discovered that huge galaxies had already burst into life very shortly after the Big Bang when the universe was just 3% of its current age by using the James Webb Space Telescope to view approximately 13.5 billion years into the past. This makes us reevaluate what we previously knew because the galaxies are so enormous. 99% of cosmology theories are in tension with them. This indicates that either the models will need to be changed or the way that science views galaxy formation must be fundamentally transformed. In any case, it is another startling discovery by James Webb. Every year, the Milky Way creates 1 to 2 new stars. During the duration of the cosmos, these galaxies would have to be producing hundreds of new stars every year. These galaxies will test the limits of our knowledge of cosmology. If even one of them is real, it would challenge our fundamental understanding. Even while all available data indicates that these celestial objects are galaxies at this time, astronomers haven't ruled out the possibility that some of them may actually be huge quasars or supermassive black holes. Nevertheless, from the mass that has been found, the known mass of stars at this stage in the history of the universe is up to 100 times greater than was previously believed to exist. This is a remarkable change. Even if the sample size is halved, the huge galaxies were not seen in earlier Hubble Space Telescope images of the early cosmos. But JWST is nearly 100 times more powerful than Hubble. Since its launch, the Space Observatory has lived up to its promise of reading the oldest chapters of the universe's history in its tiniest glimmers of light. This is not the first time James Webb has made us reevaluate how we perceive the universe. It only discovered a groundbreaking revelation regarding the Big Bang theory last year. By July 2022, the telescope had reached its deep space destination, and its instruments had been put through their paces. Shortly after, its long-awaited first year of science observations began. When Webb released its first set of images, it proved that it was worth the wait. It showed us the universe like never before. It showed us that the universe as we know it might be stranger and more complex. Rowanadu was sitting at home when he found the galaxy that nearly broke cosmology. As his algorithm dug through early images from the James Webb Space Telescope, Naidu shot to attention. It had sifted out an object that, on closer inspection, was inexplicably massive and dated back to just 300 million years after the Big Bang, older than any galaxy ever seen before. At that moment, Rowan knew that it might be the most distant starlight we had ever seen. Days later, he published a paper on the candidate galaxy, which was named Glassy 13, and the internet exploded. The extraordinary discovery of this galaxy, just weeks into Webb's full operations, was beyond astronomers' wildest dreams. The cosmic dawn now started to look like a bright cosmic afternoon, and with each new day, it seemed claims of yet another record-breaking earliest known galaxy would emerge from one research group or another. Everyone was freaking out, said Charlotte Mason, an astrophysicist at the University of Copenhagen. We really weren't expecting this. In the weeks and months following Webb's findings, surprisingly mature galaxies blindsided theorists and observers alike. They have been scrambling to explain them. Could the bevy of anomalously big and bright early galaxies be illusory, perhaps because of flaws in the analysis of the telescope's initial observations? If genuine, could they somehow be explained by standard cosmological models? Or just maybe, were they the first hints that the universe is stranger and more complex than even our boldest theories had supposed? At stake is nothing less than our very understanding of how the orderly universe we know emerged from primordial chaos. Webb's early revelations could be poised to rewrite the opening chapters of cosmic history, which concern not only distant epochs and faraway galaxies but also our own existence here in the familiar Milky Way. The previous distance record holder existed between 13.3 billion and 13.4 billion years ago, or about 400 million years after the Big Bang. Webb confirmed the distance to that galaxy and came back with three more, whose light comes from as early as 325 million years after the Big Bang. That is immediately after the Big Bang in cosmic scale and throws the cosmic dark age out the window. And not just that, these galaxies are also surprisingly pristine, chemically speaking, lacking in elements heavier than hydrogen and helium. We don't see that in the present-day universe. It could mean that not many of the galaxy's stars have died in supernova explosions that spread heavy elements around the universe, which suggests the galaxy's original stars were not extremely massive. In distant galaxies that lie behind a massive galaxy cluster called Abell 2744, more galaxies were found than expected. Before JWST observed the cluster, astronomers predicted it should find effectively zero galaxies from 13.2 billion years ago. But they found two. So something's a little bit weird, said a scientist. This could mean that galaxies formed earlier and faster than thought. All these new galaxies are exciting because they could be responsible for making the universe transparent to visible light, a process astronomers call reionization. Before the first stars ignited, the universe was filled with a hot, dense soup of particles. The first stars and galaxies bathed the universe in ultraviolet light, splitting electrons off hydrogen atoms and allowing light to zip through, until it reached JWST. The new data gives us constraints on when this process started, ended, and which galaxies were the culprits. With time, more data will be unveiled, and who knows, if Webb breaks its own record and finds something beyond the Big Bang, that will just break our cosmology like a piece of glass. But hey, what is science if not constantly challenging what we know and updating our knowledge in that process? What do you guys have to say? Drop in your comments below, and don't forget to subscribe.